So welcome students to 300 questions concept. Now I'll be doing with almost I've covered the syllabus of this particular chapter. This is alkali earth metals and alkaline earth metals as well as alkali metals. So now let me combine, like I've procured almost 300 questions which are very important for your examination point of view. This 300 questions will include simple, that is normal ordinary thinking skills. It will include average as well as hot students, so the high order thinking skills also. So please grade 11 students also try to concentrate, so that will be revision for you all. So as my board is a bit smaller, I try to pick up from the book only directly. I'll be solving all the questions. I'll try to complete all the 300 questions in 2 or 3 days. Done. Fine. So when I have to speak about the first question, which is related to your alkali metals and alkaline earth metals, that is S block elements. What does this question say? It says, right, one thing you should remember, there will be certain questions which have options more than 2 correct. There is mostly you have only one option correct, but some other questions where 2 options also will be correct, 3 options may be also correct. So let us see that how to do it. So in this particular question, they've given me ionic carbides undergo hydrolysis and produce hydrocarbons. Which are the correct products formed during hydrolysis, right? What are the correct products? So you should know the reaction, which is the correct product, then combine. Here they've given aluminum carbide gives us acetylene, calcium carbide gives acetylene, boron carbide gives methane, magnesium carbide gives propane, they said. So you need to know the reaction first. That is the reason I've done the whole syllabus first, so that the reactions are clear for you all, and then this. Now let us solve this. The first one, aluminum carbide gives acetylene. So what is the formula? So aluminium Al4C3, when it combines with, because they undergo hydrolysis, is said H2O, what will you get? Aluminium hydroxide plus the leftover is methane, right? So the first one, aluminum carbide and hydrolysis gives methane, but they've given acetylene, correct? So this is a wrong option. They want us to give the correct product. This is wrong. In the second case, calcium carbide. So let me write the calcium carbide, this one. So when I have to write the calcium carbide product, CaC2, fine. So it's calcium carbide when it combines with water. So what do we get? Again, calcium hydroxide plus, you will get acetylene now, C2H2. So this is correct option. The third one, let us go to boron carbide. It undergoes hydrolysis. Again, this forms this is boron hydride or beryllium. Okay, beryllium carbide also. Let this be beryllium carbide. Yes. So this becomes beryllium hydroxide. Beryllium hydroxide taken twice, plus this becomes CH4. Right? If you balance it, so CH4. So methane is right. The last one, magnesium carbide, Mg4C3 plus hydrolysis gives me magnesium hydroxide plus C3H4 propane, right? So now what they gave me, which is the correct product formed during hydrolysis, they said. Fine. So when I have to speak about correct product, C2H2 acetylene, isn't it? Calcium carbide, acetylene is the correct product. This is one option, right? So I said there may be 2 options, so two or 3 options. So calcium carbide giving acetylene, this is correct option. Beryllium carbide with hydrolysis gives methane, this is also correct. Magnesium carbide giving propane, this is also correct. So the options are B, C, D. All the 3 are right in this case. So there may be some questions where 3 options are right, but you should be careful with these reactions. You need to memorize these reactions, then only you can apply in this. So let us come back and see the next question. So in the next question, what do they give me? They've given me select the correct statement. Yes. So select the correct statement here. The stability of peroxides and superoxides of alkali metals increases with increase in size. Okay. Right, increase in size of the metal ion due to stabilization of large anions by larger cations through lattice energy effects. They've given a condition where the stability of peroxides, they're speaking in terms of stability of peroxides. Right. The next one, lithium. Okay, whether this is right or not, let us see. Because the concept, there may be 2 or 3 options also correct, I said. Fine. So this statement is 100% correct. So the first option A, right. Let me come back. Lithium fluoride is less soluble due to high lattice energy, and CSI is less soluble due to smaller hydration enthalpy. Yes, this is also right. option. The next one, sodium hydroxide does not form hydrated salt. And okay, the last one, sodium carbonate is less stable than sodium bicarbonate. This is also right, isn't it? We have already given the reason in hydroxides formation. Sodium carbonate is less stable than sodium bicarbonate. Now what is the select the correct options? All three. Why is this option wrong? Sodium hydroxide does not form hydrated salt. That is, sodium hydroxide, when I have to see, is it a salt? No, sodium hydroxide is a base, isn't it? Right, first of all, it is a base, does not form hydrates, so the concept only is wrong. Fine, so this option is wrong, remaining all are correct. So the correct answers are A, B, D. So I am just giving you a clue, you may have three options also to correct. Right, so let us go back to the next question. Here in this particular question, what did they give me? 2-ethyl anthraquinol when oxidized in air produces. Okay, 2-ethyl anthraquinol when oxidized. Let us write the structure first. 2-ethyl anthraquinol means one ring here, this is the second ring, this is the third ring, right? So this one correct. So in this particular thing, in this way, so this one bonds here, so this is 2-ethyl anthraquinol. So ethyl group is here, CH2 CH3, 2-ethyl okay, anthracene, that is quinol. This it, quinol means in the second one all OH groups are present. This is 2-ethyl anthraquinol. Now this is oxidized. When oxidized is it, you are adding oxygen to this. When you are adding oxygen to this, during this process what happens, the hydrogen is rolled out. Right, addition of oxygen, removal of hydrogen from where, this hydrogen and this hydrogen is removed out, and what do you get? You're going to get 1, 2, 3. Right, the CH2 CH3 is there only, and this is also there. This OH gets oxidized to double bond O and double bond O. Now what is this? This is quinone, 2-ethyl anthraquinone. This is 2-ethyl anthraquinol, all this is quinone. Right, fine. So now what is released? Hydrogen gas is released. Now what do they ask during this process? What else is left along with this? These two means when this process is happening, along with that, when I have to see the leftover product, hydrogen gas means this further combines and forms hydrogen peroxide. Right, so the byproduct of this is hydrogen peroxide. This is the correct option. Fine, so this is how you're going to do. Now let us see the next question. In this next question, which of the following is true about nascent oxygen? They asked me. Nascent oxygen, which is right? Which of the following concepts of this one is clear? Right, so most reactive than molecular hydrogen. This is one concept they've given me. Then they've given me it can be produced in situ. Fine. Then they've given me it shows similarity exactly with hydrogen in the reaction. Then reduction reaction. Then third option, A and B, they've given me, both they've given. Right, so in which of the following statement one is true about nascent hydrogen? So if I have to speak, option A, nascent hydrogen, we very well know it is more reactive than molecular hydrogen. Correct? Right. So the second one, it can be produced in situ. That is a known fact. It can be produced in situ. That is also fine. This is also correct. A and B are correct. Show similarity exactly with hydrogen reduction reaction. Wrong, isn't it? It doesn't show similarity with hydrogen reaction with hydrogen. So the option is first option, A and B. Both are correct. This is how you're going to reason it. Now let us see one more question. Gradually we'll go into the concept now. So now what do they give here? They've given me in alkaline medium which elements can produce hydrogen. Right, so what actually is this? A particular metal which reacts with both acid as well as base is called an amphoteric oxide. That means when they speak on both, when they react with acid and base, they're going to release what? Hydrogen. That is what they've given here. They said in alkaline medium which elements produce hydrogen. Whenever you see this concept, which element produce hydrogen, that means they're going to speak about the reaction of the particular metal with acid as well base. What is that? Which reacts with acid and base? That is nothing but amphoteric metals. metal oxides, metals. Now what are amphoteric metals? Remember, zinc is an amphoteric metal, aluminium is an amphoteric metal, tin is an amphoteric metal, lead is an amphoteric, aluminium, okay, written already, aluminium is amphoteric metal. All these are amphoteric metals. Along with that, even silica also comes under that combination. Here carbon is not amphoteric, isn't it? So the combination here is zinc with the other one. So this is the correct option for this. So remember, the amphoteric metals which will react with both acid and base. If zinc reacts with HCl, it will become zinc chloride. If it reacts with sodium hydroxide, it becomes sodium zincate. So this is the thing. Now let us come back and see the next question. So in this next question, what do they give me? The oxide that gives H2O2 on treatment with dilute acid is, they've given 4 oxides which gives H2O2. So for that you should know the reactions first. Let us write the reaction. I already given this hydrogen peroxide, not done, S block I did. So in this particular thing, let us see. So PbO, first one, reacts with dilute acid, means you can pick up HCl. Then what will happen? It will become PbCl2 plus Cl2 and water. First one. Second one, what they want? Oxide that gives hydrogen peroxide. No, hydrogen peroxide is not evolved from here. Let us see with Na2O. Na2O2 it should be, right? Yes. Na2O2 plus HCl. It gives us, what does it give? NaCl plus hydrogen peroxide. Okay, our hydrogen peroxide is there here. The next one, let us see, MnO2 plus HCl gives me MnCl2 plus Cl2 plus water. Okay, here also there is no hydrogen peroxide because I need to find where is the hydrogen peroxide form. Let us write the reaction of TiO2 plus HCl gives me TiCl4 plus water, TiCl4 plus H2O. Correct. So this is also done. Fine. So are we finding any H2O2? H2O2 is observed here in Na2O2. So this is the correct reaction is Na2O2 on treatment with dilute acid gives us hydrogen peroxide. This is the reaction. For that, reactions are very, very important in inorganic chemistry. So let us do the next question. So here in the next question, which of the following statement is not correct? Right? Is not correct, they said. Fine. So, I should say which is not correct. Like sodium, baking soda, that is sodium bicarbonate, is more soluble than sodium carbonate. So let us first see this. It is more soluble than sodium carbonate. Okay. Now, if I have to start reasoning, is it the correct statement or not? Let me see. Here only I am getting doubt. What is this? When I have to speak about sodium bicarbonate, what will happen? Sodium bicarbonate, when it is dissolved in water, what does it do? It's going to dissociate into water and sodium hydroxide and carbonic acid, right? Sodium hydroxide and carbonic acid, and that carbonic acid further breaks up into water and carbon dioxide. Correct, that's this one. But here when I have to speak about sodium carbonate, when you dissociate, it breaks up into sodium hydroxide, water and carbon dioxide, isn't it? Right. So which of the following statement is not correct, they said. So I think my first option, let me again come back after I got one clue for the first answer. Next one, sodium hydroxide is caustic soda, correct answer. Sodium bicarbonate is also used as antacid, correct answer. Ne2CO3 is used in the manufacture of soap and glass. All three are correct. So the option which is wrong is the first one, right? Fine. So why did I say sodium carbonate is more soluble? No. First of all, sodium carbonate, as soon as you dissolve it in water, this will break up into sodium hydroxide plus water plus carbon dioxide. Simple, as soon as that. But when it comes to sodium bicarbonate, NaHCO3, when you dissociate into water, this will first break up into H2CO3 plus sodium hydroxide. This H2CO3 further breaks up into water and carbon dioxide, isn't it? Or H plus plus HCO3 minus, isn't it? So this is how. So the correct answer is NaHCO3 is more soluble. No, it is less soluble compared to Na2CO3. So the correct answer is A. Correct option is A. Right, now let us see the next question. Which of the following statement is not correct? Fine. What do they give me? KCl is a substitute for NaCl for patients of high blood pressure. Okay, not correct. I need to take out. Fine. The next one, this is correct, isn't it? KOH is a stronger alkali than sodium hydroxide. Okay, that is also right. KOH is used in the manufacture of soft soaps. That is also right. NaOH is a non-deliquescent white crystalline solid. Okay, this is where is the mistake. NaOH is non-deliquescent. What is deliquescence means? Which absorbs moisture. So it's absolutely wrong, isn't it? Sodium hydroxide pellets, as soon as you leave in at room temperature in your lab, these sodium hydroxide pellets, they start absorbing moisture maybe after a duration of 40 or 45 minutes, and they'll start turning into liquid. So sodium hydroxide is deliquescent. It absorbs moisture, and hence it has to be stored in an airtight container. We will store it in an airtight container so that it will not absorb moisture. So the wrong option, the wrong answer for this is the answer. Sodium hydroxide is non-deliquescent. Instead, it is deliquescent. What is that? We said it absorbs moisture. Right, so let us see the next question. What is the next question? Which of the following statements regarding the oxides of alkali and alkaline earth metals is not correct? Right, so what did they give me? They've given a very big question. Let us read one after the other. What should I do? Which is not correct? I should find which is wrong in this. First of all, the first question: the reactivity of K2O towards water is more than Na2O towards water. Okay, right, when I told you the oxides, the first this is an oxide concept also, I've told you the same. So the reactivity of K2O towards water is more than that of Na2O. Yes, that is obviously that 100% right. Next one: the oxides of alkaline earth metals are more basic than those of alkali metals. This is wrong, isn't it? Why is this wrong? Because the oxides of alkali metals are basic, I accept that, but they're less basic than alkaline earth metals. Right, so why? What is this? Because what should you speak in terms of? Because alkaline earth metals are less electropositive, isn't it? So here they are more basic, they've given, but my justification is they are less basic. Why they are less basic? What is the concept? They are less electropositive. What is less electropositive? Means the ability to donate that pair of electrons or donate that OH minus ions. Correct. So why? Because the size is smaller. When I go from left to right in the periodic table, the size becomes smaller. When the size becomes smaller, it's very difficult for me to release that OH minus ion. So alkaline earth metals are less electropositive. That means less basic. Less electropositive means less basic. So now what is this concept now? Come back. The oxides of alkaline earth metals are more basic or less basic? No, less basic. So this is the correct option. Means the answer should be, this is wrong statement. The answer is B. Let us see this also. MgO is used as a refractory material for lining electrical furnace. This is right again. The next one, the milk of lime and lime water is two different solutions. Basically, when I already told you in last video, that is your calcium hydroxide, when it is in the form of a suspension, then I call it as milk of lime. When it is as a clear solution, I call it as lime water. So both are the same, but only the physical state is different. So the answer is, this is the wrong statement, this is the justification. Right, so let us come back and see the next question. Very interesting, isn't it? So what is this? Which of the following statement is not correct? Again, not correct statement only. They are asking us to find the different reasons for each. Right, so let's see. KOH is a stronger base than sodium hydroxide, which is not correct. Okay, let us see this. Whether is less strong than sodium hydroxide, it seems. This is wrong, isn't it? Why is this wrong? First only I got the answer. Why is this wrong? Basically, let us justify. KOH is stronger than NaOH. That is the first important concept you know. They said less strong alkali. It's stronger than NaOH. Why? As its solubility, that particular solubility thing is based on their, like, we speak in terms of the molar basis. We speak the term, or we speak the concept in terms of molar basis. When we speak in terms of the solubility in the molar basis, KOH is stronger than NaOH. That is the main thing. So what did they say? The first, which is not correct. So the first answer is correct. Let us see. Milk of magnesia is an aqueous solution of magnesium hydroxide. That is right. Mg+2 ions are not precipitated with addition of ammonium hydroxide in the presence of ammonium chloride. This is also right. Next, calcium oxide is less stable than magnesium. This is an MgO2. Yes, this is also right. So the wrong option is this, because KOH is stronger than sodium hydroxide. You need to see the options and remember the concept. Yes, let us go to the next question. What do they give me? When chlorine is passed through moist slaked lime, right, the compound formed is moist. Okay, chlorine is passed to moist slaked lime. Slaked lime is nothing but calcium hydroxide, isn't it? Fine. So what is the product formed? Let us write the reaction now immediately. Moist slaked lime, that means calcium hydroxide plus chlorine. What do we get? We are going to get a product that is CaCl2 plus, I'm not balanced, right? Now we've already seen this reaction, isn't it? Now calcium chloride, what happens here when it combines calcium hydroxide, when it combines with chlorine, it's going to form calcium chloride, that is calcium oxychloride, that is bleaching powder plus water. So the correct option for this is CaOCl2, right? So this is the right one. Let us see the next question. Here in this question, what do they give us? The solubility of hydroxides of alkaline earth metal increases down the group. Fine. So first of all, when such question is given to you, you should remember only one concept. What is that concept? Solubility. If they give you, what did I say? I said if hydration enthalpy is greater than lattice enthalpy, the particular salt is soluble. If the hydration enthalpy is less than lattice enthalpy, the salt is insoluble. Remember this. Fine. Let's come back and see. What is it? The solubility of hydroxides in alkaline earth metal increases down the group. Fine. So it increases down the group. That means I need to reason this according to this. What do they say? The decrease in lattice enthalpy is more. Solubility of hydroxide is increases. That means when it is increasing, that means it is soluble in nature. When does it soluble? When the lattice enthalpy should be lesser. So in the first case only I got the answer, isn't it? The decrease in lattice enthalpy is more than in decrease in hydration enthalpy. The first answer only is this, because this is, I'm trying to satisfy this option with this. So the correct answer for this particular concept is A. Fine. So next, come back. Next question. What do they give me? A compound which can be used in space vehicles. Fine. So which can be used in space vehicles both to absorb carbon dioxide and as well as to liberate oxygen is a compound which can be used in space vehicles for carbon dioxide in this one. So what is this option to absorb carbon dioxide, liberate? They've given us sodium hydroxide, then they've given us Na2O, then they've given us calcium oxide, then they've given us sodium hydroxide. So what is that used in the vehicle? Fine. So next, if I have to speak such in terms of such questions basically are direct questions, isn't it? So you need to just have the information about this question. So if I have to speak about the answer for this, what is this? So for such questions, the correct answer is Na2O2. So this is the correct option. Direct answer. There's nothing. Remember. So it can be used in space vehicles. If they speak about submarines, try to KO2. If they give you space vehicles, the correct option is Na2O2. Fine. So let us see the next question. What do you give me? Which will give N2O on heating? Okay, again reactions. So let us do this. N2O. So which of the following compounds on heating should give N2O? So let us write that question. What is that? Ammonium nitrate, NO2, on heating gives me nitrogen gas plus 2 water molecules. Correct. Ammonium nitrate. This is over. And next one. NH4, NO3 on heating. What will happen? It gives N2O plus water, gaseous state. Ruled out. Okay, I've already got the answer, isn't it? N2O I've already got. Next, NaNO3. Let us see. NaNO3 on heating gives me NaNO2 gas plus oxygen gas. If I have to speak about LiNO2, so this becomes LiNO2 breaks up on heating into Li2O plus NO2 plus oxygen. So the correct option is ammonium nitrate on heating gives me N2O. This is the correct option according to the equations. Yes. So right, so let us see the next question. What is the next question? Choose the correct statement. Fine. So they gave me beryllium carbonate is kept in atmosphere of carbon dioxide since it is least thermally stable. Fine. Correct statement, according to me, yes, this is right. Beryllium fluoride forms complex with NaF in which beryllium goes with anion. Okay, beryllium dissolves in alkali forming beryllium BOH taken 4. Okay, that is also right. Which is, choose the correct, that is one, that complex. Okay, I should say fine, that is not appropriate. Then BeF2 forms complexes with NaF in which B goes with cation. Okay, so now according to the analysis, let me see. Correct statement I need to find. First one, if I go into the depth of the topic, that is wrong basically. Second one, BF2 forms complexes, that is also wrong. Third one, salt forms dissolves in alkali forming that coordinate complex, that is also wrong. What is the correct statement? The correct statement, if I have to speak, the correct answer is Na2, because it's going to form a complex with this. Fine, so I need to put the correct statement. So according, I need to remember the concept. Okay, let me see this if I can justify. What is this particular one, BF2. Okay, let me see. Beryllium F2 combines with NaF. Fine, what is that? It's going to form a complex, that is Na2. If I take 2 moles of this, Na2 BeF4. Okay, so here they said BeF2 forms complexes with NaF in which beryllium goes with cation, but beryllium is going with anion. Right, so my whole analysis is really wrong. What is that? Beryllium is going with anion, so this is a wrong option. Beryllium, this is correct, this is correct, this is also correct. Right, so the answer is A, B, C, all 3 are correct. So this is how it forms. It does not go with the cation, it goes with the anion. This is where you need to be careful. Yes. Next question. Setting of plastic of Paris. Setting of plaster of Paris or plastic of Paris. Setting of plaster of Paris, we've said. This is plaster of Paris, is it? What is that? So basically, when I have to speak plaster of Paris, only one reaction which I have already taught you. CaSO4 dot 2H2O, so half H2O hemihydrate by 3/2 H2O gives us CaSO4 dot 2H2O. This is gypsum, isn't it? Yes, that is plaster of Paris. This is gypsum. Simple. So here, what are they asking? They are asking setting of plaster of Paris, right? Is it oxidation? No. Combination with atmospheric carbon dioxide? No. Dehydration? No. It is hydration leading to another hydrate, right? So it is a hydration, addition of water to form another hydrate. So the correct option is D. That's it, isn't it? Simple. The next question. What do they give me here? Which of the following, which is the most stable halide of alkali metals? So basically, whenever they ask you about the stability, what concept should you remember? Just simple. Stability of the particular thing. Speak in terms of delta H formation, standard delta H formation. This formation of delta H, the standard enthalpy of formation. So standard enthalpy of formation you need to speak. Now what is this? If delta H value is more negative, okay, let me write. If the delta H value is more negative, then the particular halide is stable. If there is stable, remember this. So now when I have to speak about the delta H value for NaF, how much is that? 569. Here for this NaBr it is minus 360, NaCl is minus 411, here it is minus 258. Now I said more is the negative value of delta H, more is its stability. So among all, NaF has a maximum value. That's why this is the most stable halide. So this is your concept. Remember this. Fine. Yes. So next one. Next question. Which ion is paramagnetic? They said. Okay. So when they give you paramagnetic concept, remember what is this? Paramagnetic is nothing but number of unpaired electrons, isn't it? So number of unpaired electrons. How do you take this? Just simple. I'll tell you. Calculate. Let me take KO2. So KO2. How much is this? The atomic number 19. One oxygen is 8, one more oxygen is 8. Together 35. 35 means it is nothing but odd number, isn't it? So when it is odd number, that means it is paramagnetic in nature. paramagnetic. Next one, if I have to calculate K2O2, if I calculate, I get 54 electrons. There's even K2O, they get 46 electrons. Okay, NO2, I get 23 electrons. Odd one out, odd one electron you have, isn't it? So odd one out. But here paramagnetic is, and here there's a small deviation also when you draw the structure because of the resonance. So KO2 is only one which is paramagnetic. Try to calculate the number of electrons, you will get to know. Fine. Next question, what are the which are involved in various physiological functions in animals? So simple, isn't it? You need to have the basic information. Sodium, Na plus, animal function, they said physiological functions in animals. So Na plus, where is it used? It is used in muscle contraction. So muscle contract, there are many uses, but I'm just writing the basic one, muscle contraction. And I have to speak about K plus. It is used as nerve cell transmitter in animals. Very important function, nerve cell transmitter in animals. Correct. When I have to speak about magnesium, Mg plus 2, it is used in aircrafts, bulbs, flash, different metal, like, write that, aircrafts, bulbs. Fine. So this is in nerve cell transmitter in animals. Now Cu plus is used as alloying. It is used in alloying, maintaining fluids also. Alloys, it is used in making alloys. Right. And potassium, one more important thing I forgot to say, it is used to maintain fluids. Potassium maintains fluids and electrolytes. Fluids and balances the electrolytes in the body. So the correct option is potassium, which is used for in the physiological function of animals. Right. Next question. Select the correct statement or statements. CaCO3 is more stable in a solution of carbon dioxide than in water. Okay. Argonite is a metastable form of calcium carbonate occurring naturally. Calcium carbonate cannot be decomposed by heat. Lithium nitrate on heating is LiNO2 and oxygen. Okay, I need to find the correct answer, correct statement. Basically calcium carbonate is more soluble in a solution of carbon dioxide than in water. It's 100% correct option, isn't it? Yes. Next, argonite is a metastable. Okay, what is argonite? Argonite basically is a mineral consisting of calcium carbonate. Fine. So it is a metastable form of calcium carbonate. Yes, it is right. Yes. Now let us see the wrong answers. Calcium carbonate cannot be decomposed by heat. Wrong, isn't it? Why? Because calcium carbonate on heating gives me calcium oxide plus carbon dioxide. Lithium nitrate and sorry, and heating gives, right, nitrogen dioxide, isn't it? Not oxygen. So this also is a wrong statement given. Fine. Like lithium oxide plus nitrogen dioxide, this is also wrong statement. So this is also wrong. This is wrong. The correct option is A and B. This is what is important. Next question. Let us see the next question. So which of the following mixtures cannot be prepared? Fine. Which of the following cannot be prepared, they said. So when I have to speak about this, I'll just directly tell you the answer. The correct answer is this. This cannot be prepared. Why? Because when, let me write the reason. Because Na2CO3, when you like these two, when these two combine, okay, let me write the reaction. NaHCO3 plus NaOH. When they combine, what do they form? They form Na2CO3 plus water. Right. So now the carbonic acid, whatever is there, is still an acid in this case, isn't it? When it's still an acid, what can you do? This bicarbonate, it can lose its proton to give CO3 because it's still an acid. When this dissociates, this becomes H plus and CO3 minus. So it can give H plus proton to give CO3 minus. So CO3 minus is a conjugate base of this, isn't it? That is why this combination is not possible. It cannot be prepared. The reason is, say CO3 is still an acid, and this one can always lose its proton, isn't it, when it dissociates. So, and it gives carbonate of its particular conjugate base. Done. So let us see one more question. NaOH finds its use in, okay, direct question, which it finds its use in paper industry, it finds its use in soap industry, it finds its use in rayon industry, right? direct question. Let us see next question. Na2SO4 is water is soluble, but barium sulfate is insoluble. The same question repeated. So you should always remember what is the clue in this. Hydration enthalpy should be greater than lattice enthalpy for something to be soluble. So according to this concept, I have already reasoned this question earlier. According to this concept, the correct answer is B, because hydration enthalpy should be greater than lattice enthalpy, then that is soluble. Fine. So that is the answer. Fine. So let me come back and do subjective problems in my next video. Very interesting subjective problems are there. We'll be doing so many questions like that, still 300 questions, many more to add on this. First of all, try to revise the earlier chapters which I taught you, the earlier concepts, and then only come back to this, then only you will understand them.